All right, so I have a question here. Calculate the future value of an ordinary annuity where you invest 1,000 at the end of each year for 5 years and the annual interest rate is 8% compounded annually. Okay, so here we want to calculate the future value of an ordinary annuity, meaning you're putting money at the end of each year. Okay, anytime you hear the time period is at the end, equate it to an ordinary annuity. So we want to calculate the future value, okay, of this annuity. So basically, if you're putting 1,000 at the end of each year, so year one you put a 1,000, year two you put a 1,000, year three 1,000, year four 1,000, year five 1,000. Okay, and you'll be earning interest. You want to find out how much would you have in total, basically. So this is the formula for the future value of an ordinary annuity. A represents the equal amounts that you'll be putting in. In this case, it's these 1,000s. R just represents the rate. T is the time. So they've told us it's compounded annually. All right. So whenever there's a compounding, always remember divide the rate by the number of compoundings. All right. And multiply the time by the number of compoundings. Okay. Anytime there is you hear about compoundings. Now in this case here, our interest is compounded annually. So the number of compoundings in that year is just one. Okay. So basically this it won't have a great, it won't change anything in this formula. So our equal payments 1,000. So A replace it with 1,000 in brackets 1 plus the interest rate is 8%. So convert it into a decimal 0.08 over number of compoundings 1 divided by, oh, put here in brackets, to the power, they said for 5 years, so our time is 5, t is 5. We multiply the timing by the number of compounding, so here 5 times 1. And here we put a minus 1 over our rate, which is 0.08, divided by number of compoundings, which is 1 here. Okay, so 0.08 divided by 1, that is 0.08. Even here, 0.08 divided by 1, that is 0.08. 5 multiplied by 1, that is 5. 1 plus 0.08, that is 1.08 to the power 5 minus 1 over 0.08. Okay, so we find out what is 1.08 to the power 5. That is 1.469. Okay, 1.08 to the power 5 is that's 1.469. 1.469 minus 1, That gives us 0.469 So it says 0.469 divided by 0.08. So 0.469 divided by 0.08, we get 5.866. It's a 1000 multiplied by 5.866. We get 5866. Yes. That is how much we're going to have at the end. Any questions? Okay, so we move to question 2. Says, calculate the present value of an ordinary annuity where you will receive 2000 at the end of each year for 6 years. The annual interest rate is 10%. So here now we are calculating the present value of this annuity. They've already told us it's an ordinary annuity, but if in the question they don't mention what type of annuity it is, if you hear that this annuity is paid at the end of the whatever time period it is, it's an ordinary annuity. If it's paid at the beginning of that time period, then it's an annuity due. Okay, so we get our present values here. Present value for an ordinary annuity equals A, open brackets, 1 minus 1 plus R the power negative T divided by R. So here in this question, our A, which is the equal amounts that will be paid out or received, which is 2000. One minus. Our rate is 10%, so 0.1. The time is 6 years, so to the power negative 6 over 0.1. Okay. So we start with our tabulations in the brackets. 1 plus 0.1, that is 1.1. So 1.1 to the power negative 6 0.564. We have 1 minus 0.564. 0.64 divided by 0.1 here, multiplied by 2000 here. Okay, so we do our tabulations. 1 minus 0.564, that is 0.436. 0.436 divided by 0.1, that is 4.36. Okay, so we're going to say 4.36 multiplied by 2000, 8,720. Any questions?